Welcome to this tutorial, and today we're going to be looking at how to connect multiple HC-SR04 ultrasonic sensors to an Arduino using a 74HC595 bit shift chip. If you saw the previous tutorial I did on connecting up multiple ultrasonic sensors, you'll have noticed that for each time we use a sensor, if I just switch over to this other screen, each time we use one of these sensors, we use a trigger pin and an echo pin. Now that means that if you want to use 3 of these, you're going to use 6 pins on your Arduino. Now I was quite happy with the setup that I had until I realized that I wanted to use 6 or 7 ultrasonic sensors, and of course I need the motor driver for my Arduino powered car. And at that point I suddenly realized on my Uno I was going to run out of pins. Now I could have just bought a Mega, I suppose. I've got some here, but I'm a Scrooge, I didn't want to, and I was just wondering if there was another way. And I remember from a project I did with my model railway that I used these particular chips to multiply the number of basically the output pins that I had. So I decided to have a go and get this thing to work with these sensors. Now in this tutorial I'm not going to go into great detail on how to use the 74HC595 chip. However, there will be a link on the Digital Town website that goes with this particular tutorial, and it's a link to part of the Arduino site, and it's got a really good explanation of how to use these chips. One of the great things about them is they can be daisy chained, so as you can see here you can connect one on top of the other, still using only 3 pins from the Arduino. So basically you can get as many outputs as you want. Now one thing about these chips, they only do outputs. So unlike your Arduino pin where you can swap it using pin mode and either make it an input or an output, using these chips the pins are only available as an output. So what I'm going to do now is quickly swap screens and we'll have a look at a quick overview of how these things work. So the important things about these chips, obviously they only require 3 pins to make them work. And then what you see here is this is the equivalent of pin 0, 1, 2, 3, 4, 5, 6, 7. So on this chip you've got 8 outputs. It's a bit odd that the one is on the other side of the chip, on the top side of the chip. Who knows why, but that is basically how the outputs work from these chips. And then I'm going to go down to my next diagram. So now you can see the pin numbers 0, 1, 2, 3, 4, 5, 6, 7. And what I've done here is put the pin state. I've just made up these numbers. So what I'm doing is I've got pin 0 is 0, pin 1 is on, it's high, pin 2 is high, pin 3 is high, pin 4 is low, pin 5 is low, pin 6 is low, pin 7 is low. Now to get those pins to set to those states, the value that we would actually send across is exactly the opposite. So it's the value of 142 in decimal, but the way it works is to have 0 on the lowest bit. Obviously that is the lowest bit when we look at it as a number. So what the way you would go is if you wanted this pin high and nothing else, you would send a value of 1. If you just wanted this pin high and nothing else, you would send a decimal value of 2, which is 1, 0. And if you wanted them both high at the same time, 3, which it would be 1, 1. Now I've put this example in just to sort of try and help you get your mind around how these values are swapped over, But of course, in the code that we're going to do, one of the things you have to understand with ultrasonic sensors is you do not want them all firing at the same time, because if they all fired at the same time, you're going to have sounds bouncing back off everything. So the great thing is we only need to send one value at a time. Now in the example I'm going to give you in the sketch, I'm only actually using 3 sensors. I've done some with 4, and you could use 7 if you wanted. But basically, if I want to get the first pin to trigger, I just send a value of 1. If I want the second one, I'm going to send a value of 2. The second pin 2, I'll send a value of 4. So each pin, as I want to move through them, I just send a different value. So let's get over and have a look at the IDE. So here we are in the IDE, and here are the pins. I've done the pin out in the top for you. So going down to this, I've got the ultrasonic sensors. Now I cannot use the echo pin in the same way that I can use the trigger pin. When you trigger the ultrasonic sensor, you just send a pin basically low, then high, and back to low again. But when we use the echo pin, as we look down into the function, we have to use a value called pulse in on the echo pin. You probably remember this if you remember this example from the ultrasonic sensor tutorial, but that means that the echo pins have got to use real Arduino pins. So for the trigger pins, because now we're going to send a binary value, I've numbered mine sort of pin 1, pin 2, pin 3, because I found pin 0 a little bit awkward to get my head around. So the way I've done it is pin 1, I send a value of 1, pin 2, value of 2, 1, 0, pin 3, a value of 4, 1, 0, 0, because at any time I will only want a single sensor to trigger. There's some constants here for the different pins that connect to the 74HC595. In the setup, obviously some different pin modes. For the echo pins are all inputs. The 74HC595s are all outputs. And then in the loop, all I'm doing is it is using the function that we're going to have a look at in a minute, and it just calls that, and each time it calls it, it sends a different trigger pin and a different echo pin. So it's just working through my different sensors one by one. So I'm not going to go into a huge amount of detail in this particular function because it's based on a function in the HC-SR04 Ultrasonic Sensor tutorial. So it's exactly the same function, just altered to use this other chip. And what I've done is I've left the old function code in so you can see how I've got round it using the chip. So normally what we would do is we would digital write the function trigger pin low. So this time what you have to do is you've got to send the latch pin low. That stops anything changing while we're writing. Then I send out the value that I want to send through. In this case I need everything low because I wanted the pin low. I'm going to send every pin low. So I just send a value of 0. And then what I do is I put the latch pin high, and that then transmits the value through the pins and sets up the system. Then what it required was a 2 microsecond delay, and then we go through the same process again. This time I have to put the trigger pin high. So again, latch pin goes low, stops anything changing. I then send my value through, which is my trigger pin, which were those values up here, those binary values. Send those through. Again, set the latch pin high so that the values then are transmitted. delay for 10 microseconds, and then I have to set everything low again. That is basically exactly the same as was happening in the lines above, except instead of it being an Arduino pin that's sending out the signal to trigger the ultrasonic sensor, it's using the bit shift chip. Now, once the bit shift chip has done all its stuff and the unit is triggered, the function works in exactly the same way, reading from the echo pin, just as it did in the original tutorial. And here, as an example, I've got 3 sensors set up on my desk. They're all going a little bit bonkers at the moment. Hang on, let's move them to a sensible place. There they are. They're all settling down now. They're all pointing, you know, doing about 800 millimeters. If I put my hand in front of one of the sensors, you can see that it's dropped to 130, 120, moving across, starting to block second sensor. And finally, if I block all 3, they're all bouncing around the same thing, unblock one, and they come back up. So as you can see, the script works in exactly the same way. The function can be called in a very similar way, but the advantage is, of course, that you're not going to run out of pins on an Uno at the same speed that you would have normally. So if you used all the digital pins, I reckon you could get, what, 3, 4, 5, 6, 7, 8, you'd probably get 10 or 11 ultrasonic sensors. For my car, I won't be able to get that many in because I'm going to need to use some of them for the PWM for the motor, but everything else I do for the car, the L298N driver board, could all be sort of powered off another one of these bit shifting chips. So that's the end of this tutorial for today. I've gone through it reasonably quickly because I've done tutorials on the different components before, so if you need to find out particular details, there'll be links below the tutorial and more links, and all these the sketch, the circuit diagrams, and a load of other information will be on the Digital Town website. So I hope that's been useful for you, and again, if it is, click the like and subscribe. Bye for now.